Hi all, this is Mr. Yeager for Physical Science. Looking to introduce energy for the physical science class. This goes with a video that's going to follow it on conservation of energy. This one's really, as it's kind of basically saying, it's an intro to what is energy, what are different types of energy, and then a little bit of time focusing on the two main ones that we look at in science that we calculate: kinetic energy and potential energy, specifically gravitational potential energy. So here we go. So there's all sorts of energies out there, okay? When you're running, the sun obviously producing heat, all these things obviously produce some sort of energy. That last one's saying that you have energy because of the height that you are, all right? I think I have more pictures here. We got wind energy, we got cooking, okay? Basically chemical energy there as well. So there are all sorts of energy out there, but essentially energy, what I say in my AP class for physics, I go, energy is energy regardless of type. It's just how it's being used in that particular case. Where is it coming from in that particular case? But all energy gives us the ability to do something. And so that's basically what we lead to with energy. The definition of energy is a very vague one. It just says the energy is the ability to do work, all right? What does that mean? Basically, to make anything happen, there must be some sort of energy involved. If there's zero energy, there will never be any changes. The object will stay exactly as it is, and there's nothing that will ever happen to it, all right? But if there is this energy, which can be a tough topic because it's abstract, okay? It's something that the object has, but we can't necessarily touch it and feel it. We can see the effect of it based on the fact that the object will be able to do something because it has that energy. So it's that ability to do something, all right? And so we're going to look at, obviously, how you can manipulate the energy of an object. There's different things you can do. That's what I'm looking at in terms of types of change. We can change the motion of the object. That will cause that's changing the energy. You can change the height of the object. You can turn a light bulb on. You can make the gasoline move a car. It's obviously combusting and using that energy from the combustion, from a chemical reaction, to make the car do something then. If there was no gasoline in the car, the car wouldn't be able to use the engine to move, all right? So that's what we're looking at, is energy allows us to do stuff, all right? So there's different forms of energy out there, all right? And we do need to recognize what type of energy that you might have. So I'm going to try to go through as many as possible, but I mean, there's other ones that you should kind of understand just from prior knowledge, prior experience. So the first one I have listed here is chemical energy. And this is energy that comes from substances itself, all right? Chemical energy is what's inside an object. So foods contain chemical energy. That's why I have the picture there. All foods have some sort of chemical energy. How do we know? Well, if you eat that food, it's giving you energy to hopefully continue to do stuff, to continue to, in a way, live, to do the functions that your body needs to do. Gasoline is maybe a clearer one that we can really see. It has chemical energy. If I put a little bit of fire to it, kaboom, all right? It obviously has quite a bit of energy stored up inside of it. So chemical energy is the energy that's basically in all objects inside of them that we can then break apart by digesting, by burning. Thermal energy. Thermal energy is energy from heat, so fire, sun, etc. Electrical energy, energy from electricity. I mean, some of them are pretty obvious. You can't really get around the definition with the word. We have to almost use the word in the definition, okay? So that's the energy of the electrons moving in a current. Solar energy, energy from a sun. Do I have that there? Yep, there it is again. And elastic, we have elastic energy, energy from stretching or compressing an object. All right, rubber bands and springs, we'll be looking at those a little bit. All right, and a lot of other ones. There's wind, hydroelectric from water, geothermal is the heat from the earth. Nuclear is from the atoms, inside the atoms, the nucleus. And there's lots and lots and lots more out there, okay? Again, these are the most common ones that would show up on any sort of test, but you can't sit there and be like, you know, I mean, unfortunately, I can't think of any other particular one right now, but there are other energies out there that you can have involved in the object itself, okay? So what is the unit for energy? The thing is, energy is energy regardless of type. So thermal energy, geothermal, hydroelectric, solar, electrical energy, they all use the same unit called the joule, which we abbreviate with a J. Okay, that's the symbol for joule. All right. All forms of energy have the unit of J joule. Okay, it doesn't matter what type of it is. All forms of energy. I always kind of laugh when I have somebody that eventually, after we've done this lots of times, you know, they can solve for kinetic energy. They're going, no, kinetic energy is joule. Potential energy is joule. And then another question goes, find the amount of hydroelectric energy. And people go, what type? What's the symbol for that? Still joule. Joule. All right. So the two main types of energy we're really going to focus on primarily in this class, and we're going to analyze in labs and other things like that, are kinetic and potential energy. All right, I didn't have those listed in the other forms. All right, but these are the two because we're going to highlight them obviously a little bit more, focus on them a bit more. So you might already know what some of these are. So here we go. Kinetic energy, Ke, is the energy of motion. All right, when an object is in motion, it has kinetic energy. All right, kinetic energy is the energy of motion. All right. This will depend on mass and velocity. And well, might as well just show it. Okay? An increase in either mass or velocity will cause an increase in energy. All right? Kinetic energy depends on how large the object is and how fast it's moving. The formula for it, Ke equals 1/2 mv squared. All right? So this is why Ke depends on mass and velocity. Ke, we have the formula with mass and velocity, which is squared, in it. There it is, kind of written out in word form. Kinetic energy equals 1/2 mass times velocity squared. It's only the velocity that's squared. All right. And I always ask this: which of these variables will affect the kinetic energy more, mass or velocity? Well, if we think about it, all right, if you double the mass, you're going to double the kinetic energy because mass is basically there's only one mass in this formula. Okay. If I double the velocity gets squared, so you're actually going to increase the kinetic energy 4 times. All right? So mass will only double the energy. If I double the mass, it'll double the kinetic energy. If I double the velocity, it quadruples the kinetic energy. Why? Because it's squared. Velocity is squared in the formula. So which affects the kinetic energy more? How fast you're moving. So we could have a small object have more kinetic energy than a larger object if it's moving a lot faster. Okay, that's what we're looking at. So in the classroom, I show basically pictures, obviously something moving fast, something moving slow, showing different types of kinetic energies. The faster an object moves, the more kinetic energy it has. All right. If we do a quick problem, we have a 1,000 kilogram car, it's going 10 meters per second. What's the energy of the car? We use the formula 1/2. Don't forget about that 1/2, mv squared. So this would be 1/2 times 1,000 times 10 squared. Only 10 is squared. Well, there you go, just to make it clear. 10 got squared, so now it's 100. So 1/2 times 1,000 times 100 gives me 50,000 joules. Okay? So a 1,000 kilogram car going 10 meters per second, basically about 25 miles an hour, has 50,000 joules of kinetic energy. The other main type that we're going to calculate, potential energy. Potential energy is stored energy. All right, you saw there was chemical potential energy. That's the stored energy in an object, in a substance. So potential energy comes in many forms, we will say. Most of the time, though, we're going to be focused on, it'll depend on the position of the object. When I say position, this might be written in just a moment, that depends on the height of the object. How high is the object? Composition, this is related more to chemical potential energy, which we're not going to calculate. Okay?
Julie Rogers,
From there,
please come to the main office. Julie Rogers, please come to the main office. Thank you.
So there's different types of potential energy, like I said. There's elastic potential energy. This is energy stored in a spring. We're not going to calculate that one, but again, we should recognize it. Elastic potential energy, elastic energy. There's chemical potential energy. We're also not going to calculate that one. That's potential energy in food or gasoline, again, already mentioned. The one we're going to calculate most is what's called gravitational potential energy, GPE. This one depends on the object's position, specifically how high it is above the ground. The higher the object, the more energy it has. All right, so gravitational potential energy, it'll depend on two other variables too, but the main one we're going to focus on is the idea that you change the height of the object. So gravitational potential energy actually depends on mass, gravity, and height. The nice thing is they all affect the gravitational potential energy the same. If I increase any of them, the potential energy will increase. That's because my formula is GPE equals mgh, mass times gravity times height. The gravity on Earth is 10 meters per second squared, so that's basically a constant. Now you might be given a problem where you go to the moon or some other place. Obviously that will have less gravity and that will be given to you in the problem. Excuse me. Which one will affect it more? The answer is none. They all affect it equally. Okay? All three affect the gravitational potential energy the same. If I double the mass, I double the GPE. If I double the gravity, I double GPE. If I double the height, I double GPE. They're directly related. Whatever you do to one side, it does it to the other side. So, quick example problem. A 2 kilogram object is 3 meters high on a shelf. What is the gravitational potential energy of the cat? Oh, 2 kilogram cat, I said object, sorry. All right. So you'll see that you're given the mass, 2 kilograms. You're given the height, 3 meters. G is equal to 10 meters per second squared. It's going to erase. Our formula is mgh. I'm just going to multiply all three of these numbers together. 2 times 10 times 3, no squares, nothing special. Comes out to 60 joules. Okay? Excuse me. Now, a quick challenge. Okay? This is kind of what we're going to get into in the next video. In the prior problem, the cat's potential energy was 60 joules. If the cat jumped off the shelf to the ground, what would be the cat's kinetic energy just before hitting the ground? So this is what we're going to get into more in the next video. The cat is up on a shelf. Sorry, I'm just going to draw the cat as a circle. We said it has 60 joules of GPE, gravitational potential energy. It then basically falls off that shelf, jumps off that shelf, basically comes off that shelf. That GPE is going to change into kinetic energy because if any object starts falling, what happens to it? It gets faster and faster and faster. Okay? So the gravitational potential energy is going to change into kinetic energy. So the question here is, how much energy will the cat have at the bottom of the shelf? It's not going to have any more gravitational potential energy, but the energy we're going to learn cannot be destroyed. It's going to change into something else, Ke. So if there's 60 joules of GPE, how much energy of Ke should I have? 60 joules. We're going to learn energy is conserved. Energy is conserved. Your job that we're going to go through again on the next video is to figure out what type of energies is it changing between. We need to be able to do energy transformations to say it has this type and then it's changing to this type. It's still the same amount in both places, but they're different types of energies. The energy's doing something different with the object. One is just, it starts off energy because of the height. It changes into energy of motion by the time it falls and hits the ground. Okay? So that's what we're going to look at that it basically changes from one type of energy to another. And I believe that's basically it. Okay? It's going to convert from one type to another as it approaches the ground. All right? Thank you very much.